All right, we're back in the game. So we're getting started in a few seconds. Let's just wait a little bit more for the stream to stabilize. All right. So this is me in Zen mode. I'm gonna step into stream mode, make everything bigger. Cool. All right, so previously we made some progress on the server side and the client using libdata channel. We currently have a peer connection. It's not quite stable, especially on the Quest. I'm not quite sure why yet, but it seems like the Quest is overwhelmed with the update operations. And even though if they do that correctly, it just, yeah, at some point it just crumbles, and I'll go through that afterwards. For now, I just want to make sure that the microphone data is mixed properly, and it's, yeah, and then it's sent to the different players. Let me get this out of the way. All right, so let's start building, because you never know. I want to make sure I'm in a clean state. And, well, first of all, do I have enough disk space? That's a recurrent question, to be honest. It's never enough. So we are currently not in a clean state. So I want to make sure that all the changes that I'm going to make are chunked together. So I removed all of these settings here. They were not really useful anyway. Okay. So I did remove some chunks of code. The synchronization. So this is gonna wait. These were just tests to see if I can stabilize the Quest client. And a bunch of flushes here and there, just to make sure the messages are sent out. Because what happened is that the messages weren't really going out, all of them. I don't know what happened with eNet, but before flashing every send message, they were getting kind of lost. I'm not 100% sure about that, but this was a quick fix, and it actually made sure that all the packets were going out properly. Let me quickly check something. I don't know why this is not picking up the dark theme. I hate it when it's like this. Where do I even... Okay, it might not even have the dark theme. Damn. Alternative editor. General. Oh boy. Yeah, this is pretty bare bone. Yeah, there's definitely no dark theme. All right, never mind. It's not like I'm gonna be using this all day long. I'm not quite sure. So I can keep those changes for now. But I especially want to undo some here. Request, sync. These are fine because they keep track of the actions that's been taken. I definitely don't want this anymore because this is gonna stall the thread while the render thread. So that's not good. And what else? Okay, the create one. I'm gonna revert this. I want to make sure I have something to land on. It usually fails that step. On the client side, yeah, let's leave this because I want to try to wait to connect to a client to server instead of just starting loading like crazy. Okay, yeah, actually, there is something that I can, but maybe I can leave it for later. Yeah, I definitely need um, a to-do list, which I don't have right now. Might create a file here. Yeah, that would be a good idea actually. Not in Windows, but where can I have that? It would be good to have it in here. Yeah, that would be just a to-do. .txt. But I also would like to have it listed as a thing in here. I wonder if I can add. Can I? Can. What did I just do? Can I add text file to CMake so it's listed in the IDE? It will be a to-do list. Okay. Yeah, C-line mostly. Target source. Oh, just like that. Okay. Source group. Hmm. Add custom target. To do source to do. Yeah, that can do. Okay. It could have just been in the app. Yeah, maybe. Just to do here. Not txt. Yeah, it might be the quickest way, to be honest. I might change mind later. So let's go with the quickest way, which is just adding it to the private. Okay. So I'm just placing it here. Oh well, actually it's just popping, so I don't need to do much. And I'm gonna leave it down. Can I? No, I can't really. Okay, no. I hoped I could stack it there. Maybe on the side here to do just small one on the side. Yeah, that could do. But I forgot what I was about to do, to be honest. It was something about loading the chunks. Let's see. Okay, yeah. And that's going to be, make sure you don't generate chunks that are waiting, what? For, what, bro? My keyboard is going insane again. Chunks that are waiting on server data. Okay. You just make sure you're not generating those. Okay, that could do. All right, now that we have everything in place, let's do a quick compilation and see where we are at. So hopping over to the Windows binaries, that's the client, and the server is gonna be run like this. Well, actually, let's see, I might keep a debug eye on the server actually, yeah. And that's going to be run like this, server headless. Okay, so we have a debug, performance not available. Oh wait, I didn't even want to click on that. All right, server is running. Let me start a client. We have the client receiving chunk data. Okay, sync. Wow, it took a little while to sync the data. Received sync data. Okay, it's also syncing while receiving. Yeah, don't sync data that. No, yeah, that's already what it's doing probably. So just don't sync data that have no data. But I think that's what already happening. So when the client, okay, it checks whether it's actually have data. Okay, very good. Very good. So let's go back at it. And I think it's sending data already. So it is sending microphone data. But I'm not super sure. So what I want to do instead is just go to the client, which has an audio dump. Oh no, not the client. I need the server. Audio dump for each peer. I'm going to have an audio dump just like that. Expand compressor. Let me try with a little gain and see if I want to try to do a little bit of a gain. Just not too much. Just enough. So just like this it should be good enough because I'm kind of talking quietly. So I just want to make sure that there is enough decibels. This sounds about right. Okay. So back on the code. For each peer, let's field timestamp. Oh, timestamp. Okay, do it. Timestamp's gonna be 0. Just make sure it's 0. Okay, so everything is initialized now. RTC peer. Let's jump over to where it's created. RTC peer. Okay, so we are creating it here. Track on frame. So this is the on frame. I also want the open, maybe. On open. And what's gonna have an open? Oh, wait. It has... Oh, I can do that. I didn't know that. Is this a new feature? It never appeared before. Oh, that's so handy. If you just could put the end line there, would be nice. So when it is open, I probably need to capture which peer we are on. And grab RTC peer. RTC peers, yes, but not audio track. Oh, I also need to capture this. Without this, there is no RTC peers. So when I get RTC peers, I want to head over to the dump, the audio dump, and create a new file. I was going to say just the way I did here, but might have removed it. Oh no, just like this. There you go. Okay. Like this. And maybe do a quick check. Ah. Audio. And that's the player ID. Not this player ID though. I need the player ID of the peer. And that... Wait, how do I get that? RTC peer... player state, probably. Get players. Is it clients? How did I call it? Okay, clients for this peer. And the ID. Okay, so this is going to be the player's ID. And once we get that, we have a file to dump on. And that is how we are going to dump it. So again, grab the captures and go find, oops, the object. Oh, we need to decode, right. So audio source append. No, we just need this and world decoder, and the decoder is going to be on the RTC peers decoder. I hope we do have a decoder. We do have a decoder, but maybe we create the decoder when the track is open. Okay. Yeah, because this happens at the same time. All right, that should be it. Maybe we just add one final touch. That is track close, on close, on closed. Okay. Why is it not showing me the very nice? There you go. Lambda autocompletion. Now that I know it exists, I always want it. So unclosed, we need to destroy. Yeah, we need to do a bunch of things. We need to destroy the decoder because yes, we are getting opus frames, we are decoding them. So we will need to destroy the decoder. This is a decoder. We still need to capture the usual stuff. We might even close the file. And that's about it, really. We didn't create any other asset. That's cool. But there is one thing that I really wanted to change, and that's the size of the frame. Right now it's set on 480, which is 10 milliseconds worth of data. And that might be a bit too much. It's very low. It's very low in latency, but it's also, yeah, it's got a bit of overhead over. So I don't know. I need to make this I need to put this in some sort of configuration file because this is all over the places right now. All right, so we have something. Now I'm running the server. It's gonna take a little while to compile. Yeah, the build time it's going up to the roof. I don't really know why. Every time there are so many dependencies that I have to clean up. I feel like I need a little bit of music. It's too silent in here. So, YouTube library. What have we got for me today? I'm gonna go with jazz and blues. Would be nice to have some sort of player. But maybe there is. I'm just assuming there is not, but YouTube audio library player. Okay, it does Android YouTube player. Nope. Is it that bad? No, it's not bad. I like it. Skyrocketing. Bro. Why is it so high? Sorry for blowing up your headphones. Why was it so high? That was weird. Why is it so high? Damn. Okay. Something like this should be okay. So back to the game. We have the server up and running, and I will start client, new client joined, and it should grab something from my microphone. So as I keep talking, it should be recording something. Okay, there he is. The file has been created. Now I'm gonna stop, and it should close the file and have it synced. Yes, it did. Nice. Now let's play this back, hoping it's not gonna blow up. Okay, I'm gonna keep it toned a little bit down. So this is a raw file. I'm gonna need to play it back with ffplay. ffplay, yes, and it just happens to be the same file. And it should grab something from my microphone. So there seems to be something, but I can't really hear it. So I need to stop the music. Where is the music? Just pause this a little. I'm gonna crank my microphone up and play it back again. And it should grab something from my microphone. So as I keep talking, it should be recording something. Okay, there he is. The file has been created. Now I'm gonna and it should grab something from my microphone. So as I keep talking, it should be recording. Okay, so that was fine. Very good result. The problem is that the frequency is wrong, but I might just be playing that wrong in the first place. So how do I set the frequency? Audio frequency? Rate? Could be rate. It could. Damn, this keyboard again. Do I set the frequency on ffplay? Yes, that one. AF. Okay, audio frequency. I was right. No, that's fine. Stop. Just stop. No, don't record me. No, I don't want. Just go away. Audio frequency. Wait, what? FF play. Oh. 48K. Does it accept that? No, doesn't. Or 48,000. Wait, what? Audio frequent. AF. What is AF again? AF. A resample. No, I don't want resample. Oh, audio rate. Audio rate. Okay. And it should grab something from my. That's great. So it's sending the right data. Now, the next step, so let's do a bit of a bookkeeping. Oh. All right, dump audio track on the server side. Now, forward audio packets to other players. Okay, encode. And then I would say mix world audio. With buffers, okay. That's also something important to do. Mix world audio with buffers. Well, that's buffering. And then maybe add spatialization. So the thing is that, should I use mini audio? That would make sense because it's the same. It would make it easier for the logic to just... Well, not really. I mean, the audio should be played locally. Just so we don't have latency, too much latency on interaction. But at the same time, we also want spatialization. And I was wondering if we really... Yeah, how to implement this. Oh, I need a tissue for my nose. Be back. Okay, I'm back. And I would say we can go back with the music. Yeah, so I'm gonna place it as a task using mini audio. And maybe split into sections. How do I split audio? Should I don't know. I'm just saying audio. So these are all audio related. Well, not really. So this is networking. Yeah, it's in between networking and graphics. So every player is going to need a queue worth of audio frames to be sent. So I'm going to try to keep this very simple, and I'm going to say that this is a vector of a vector of floating points. And it's the audio mix. So it's a vector of frames to be sent, and those frames come from the audio mixing, and the audio mixing So we need that to happen, constant updates. Okay, that is... so how would we do that? Definitely not every time. So we don't have to do that every time there is a frame from up here. Oh gee. So we also need to accumulate the microphone data. And that's a mic buffer, and this is the audio mix buffer. Yeah, I don't know. All right. I'm pretty back. Just needed something warm to drink. Well, that's definitely warm. Ew. All right. So what's next? We have the audio mix buffer. And also the two buffers. And we need to populate them. So the microphone buffer is quite easy. That's going to be set over here. And I guess I can really just remove this. So it's gonna be useful for debugging, but not at the moment. So once it's open and it starts receiving frames, we also want to make sure that the frames, when they are received, they are also decoded. And to do that, we already have the decode. And all we need is then to go to the RTC peer and dot and place. Now we need the microphone buffer, the mic buffer, and append or pushback PCM. Okay, that's gonna make a copy, but I should move it. Then I'm afraid I'm gonna enable the... Okay, I'm gonna place this next. And then finally move it. And just hope nothing else happens afterwards. Because the compiler just won't tell me what's going on. Well, it is actually correct. I mean, it just gets emptied, so nothing bad should happen. It's just a logic bug. Well, this is super hot. It's super hot. Oh, hey, what's up? All cool. Everything is cool. I just went to grab a little warm drink. It's getting chill in here. Wait, why is this still saying upcoming? Okay. So what am I up to? Working on sending voice chat. So this is now my to-do list, and right now I'm working on the voice chat. I've set up a network connection between the server and the clients. Each of them have their own RTC, real-time communication channel, and the client will send microphone data to the server. Oh, my nose is... Yeah, my voice is getting nosy. But so the server receives all the microphones, and then it mixes them together and sends the contributions back to each player. retained. So this way we should have a clean server-side mix. So this will be the server, and then each client with, I hope this looks like a microphone. It doesn't look like a microphone. Damn. Oops. How do I make a microphone? It should be like a cone. Okay. Kind of. Does it look like a microphone? Okay. So it sends microphone data. And then it receives back world mixing. Which I think is the best solution if there are going to be lots of players. Not that I think there are going to be lots of players, but this is a problem that's fixed, that solves. It's going to load the server though, so I will need a space partitioning at some point where you only get contribution for your nearby players, and maybe in the future you also get contributions from whole areas. So a whole area will have its own mix, and then you can get far away contribution. So you're kind of here to be, I don't know, part of a crowded place, if there is going to be any, of course. So that's the idea of it, and it's also meant to be spatialized, but that's coming next. I need to figure out how to do that. So Mini Audio has that feature, but I don't think I can use it on its own. So I'll be choosing what to use. I've recently, not recently, but I've in the past done the Oculus spatializer, but they stopped distributing the it's fun and games until traffic starts to be uncontrollable. So I'm using eNet, which is a fine library. So if you want to get into that, I suggest you to look into this. It's just a linear protocol over UDP, and it gives you reliability for things that needs to be that way. Otherwise, it's just UDP. So it's UDP with the option of having reliability, which is nice for certain things. Common update, frequent update will be sent as unreliable packets, and sometimes, like when I hit the brick, when I want to break the brick, well, that needs to be reliable because it needs to be also replicated across all the different clients. So yeah, now back to the client. What I'm doing right now is buffering clients, the client microphone contribution to the world, and each client, and then I will do the mixing at some point. I should probably also take into account the timestamp. But for now, I'm just going to rely on magic. So for each, now onto the tick. For each player, I'm gonna need to do an audio mix down of all of the other players. and then clear everything out. That hopefully is gonna make sense. Because I don't think anyone can send packets from the future, so that it should all be up to the current time. It is a queue, so there should not be gaps. If a packet comes slightly delayed, then it will be queued for the next update. It's 10 milliseconds anyway, so it's not gonna be worth much. If anything goes missing, you won't be able to hear that much, at least. You're planning on using a dedicated server or peer-to-peer? No, I'm planning to have a dedicated server. Yeah, the idea is to have a single persistent world, or at least a world split into chunks. But yeah, there is also the option of having private connections. So I also have that option in mind. It's currently implemented, so you should be able to connect. But yeah, dedicated server is definitely the way to go. But also the other option is viable. So I'm thinking of having both. And the dedicated server will be headless, so it's going to be able to run somewhere. And in the past streams, I went through building it on Linux, so that's now also a target, at least for what concerns to headless servers. So given that, it shouldn't be too much of a work to make it also run on Linux client side. But no, I don't have any plan right now. Everything is portable, so I guess the only step that I need to take is the graphics initialization, swap chain, window creation, that kind of stuff. So I've wasted a bit of time trying to run it on Alpine Linux, but that uses a different libc, which didn't work right away, and also going through the compilation of all the dependencies was a bit of a pain, and in the end it didn't even work. I was so close though, I was very close, so I think there is a good chance that it will work in the future if I will ever need to. But I also found that Ubuntu Mini is quite small, so I'm pretty happy with it. If there is anything else, I will find out a way anyway. So, alright, back to the mixing. For each peer, if the peer has some audio data, if the peer, the RTC peer, if this RTC peer has any microphone buffer, so if this is not empty, let's see, should I do the mixing for every peer? Well, it should be for every peer, so let's just do that. And how many buffers? So that's also a good question, right? How many frames? So some of the peers might have a slight different amount of frames. especially if it's not connected anymore. So if it's not connected anymore, it might just screw up with the other ones. And I'm wondering if I should leave gaps instead. So there must be a slightly better way of doing this, but for now, I might take the maximum. Yeah, the maximum might also work. So how do I do that? Mic buffer size. Yeah, I'm just going through the easiest way, which is for each peer. I should use something like ranges max element. Is it max or max element? So there's a predicate projection, but I can't really get. Okay, I can get to the projection. So the range is going to be the values. So that's a views values RTC peer. Yeah, why did you do that? This is not the way it works. And so I'm using the bottom version. Oh, why can't I even select it? No, can't really get to the one that I want to use. Okay, anyway. The predicate. Oh, the predicate already happens. Why not the projection first? So the predicate is going to be RTC peer. So that is a const ref. The predicate or the max element. No, I didn't want the max element. I just want the max. So I need what is this? RTC peer. Okay, a reference to A and B. And a.mic buffer dot size. Wait. The value is the predicate. But no, I need the element. Okay. I need the element. Is this how we get... Oh, why it's so complicated? This is not helping much. How do I get the maxi? 。 No. the max value of an array of a vector member size. Yep. Okay, range, transform. All right. This is trying a newer. Okay, I was completely out of path. So this was correct. This range is max. Max was correct. Of that thing. These views and then send them through a transform. Okay. Okay, there you go. It's already giving me the right answer. Peer.mic.size. Okay, this was shorter. But I'm screwing up some of so that is transform. This is a lambda. This is still transform, and this closes like that. Okay. What's wrong with this? Require not satisfied because void does not satisfy. What is void? So its range is max. This isn't void. Okay, straight range is max. Set views, transform. And this is a lambda that gives me... Oh, return, bro. Okay. I got the return unused. Yes, of course. And this is a size T. Come on, keyboard. Max frames. All right, we have the maximum amount of frames that we want to use. Even though this way there will always be one off, so it's not the best choice. Let's switch to the minimum amount of frames that we have, and for each peer we do a secondary other peer and other if peer is not the same peer, then we compute, well, first we create a vector of a vector of a float, which is the PCM's, come on keyboard, frames. Okay, I'm gonna call it frames. Maybe these can be const. Yeah, let's const them, and then I can deconst if I need. And the number of these is the mean frames. Well, I should initialize those. How can I initialize the vector of vectors? Yeah, let's just do the easy way. And place back, and that's going to be for 80 again. Very hard coded. Now for not const, but that's going to be, well, an auto reference for each frame. That will be a PCM in frames. We compute the contribution. So for each frame, is that how it works? No, I should do it differently. So that's going to be like this, not max frames. Yeah, max frames. And now I need to add, I'm just gonna be adding values, just stacking them on top of one another. That could work. std accumulate work? In this case, no, std accumulate doesn't work. How do I... Is there a smart way to do... float vector to another one of the same size. Okay, well, simple loop. Okay, SIMD. Wow, that's too transform. Yeah, regular transform is fine. Does it work with ranges? Yeah, show me a ranges version. Okay. This is the boy. Ah, this feels satisfying. So A is going to be frames. Okay, in A we will throw the data back in, and the other one is from the other peer dot mic buffer, and the mic buffer is going to be I frames. Okay, this looks sexy if it works. All right, so once we are done with this, at the end, we're going to remove the microphone buffers from all of them. Forgot to const this guy. Oh, I think I'm running out of time. Yeah, 10 more minutes and then I have to go. Let's see if I can get this to work in 10 more minutes. Well, even less than that. If microphone is empty, okay, so we have the frames, we have the contributions, now we compute the packets. Let me see. Do we need to compute the packets? Yes, we need to compute the packets. So where is the data being sent? Here. Okay, now this one, don't do that anymore. So don't generate fake audio anymore. But we need to keep track of the timestamp somehow. Okay, so there's still quite a lot of work, and I need to do something else. So I'm gonna have to stop it here, and I'll be back next time. to finish off this work. So it's been a good journey, and I will see you in the next stream. Have a good day, everybody. See you soon. Bye bye.